Okay guys, here we go. We're going to remind you, going back to section 8.3, about similar triangles, how we prove triangles similar. Now the easiest way that we got to show that the triangles were similar, and similarity means what? Same shape, okay, different sizes, alright? The easiest way we found was to use the double A, or in some cases the triple A postulates. So basically, if you can match up two angles from one triangle to be congruent with two angles of another triangle, then that precludes that the third angle of each would be congruent, which would be sufficient to show that the triangles were similar. And if they were similar, not only were the angles of one equaling the angles of the other, the corresponding sides are proportionate to each other. Okay, so now let's move that idea back into this, particularly with right triangles when we're looking at similarity. Okay, and actually before we go into that, we want to set up something called the geometric mean. Now, here's what is implied by the geometric mean. It's best to look at it with an example. So here's an example from the book, okay? So it says, what is the geometric mean between 4 and 18? Now, whenever they ask for the geometric mean, they're asking you to set up a ratio. The ratio is such as the geometric mean, which is what you're solving for, is listed as x in opposing positions on your proportion here. In other words, once in the denominator, once in the numerator. Whatever it is the geometric mean for, which is going to be two other numbers, are written in the other two positions of the proportion. And then we're simply going to cross multiply and solve for x. So this is what we mean by the geometric mean. So in other words, in the general example, if I were to find the geometric mean between A and B, then that would imply, okay, x over A is equal to B over x, or flipped across here, it's the same thing, because when you cross multiply, you're going to find that x is the square root of AB. So just refresh that. In fact, let's go over a couple examples on the worksheet that you're going to have. Okay, so here, all these are asking you to find the geometric mean for these pairs of numbers. So what is the geometric mean for 3 and 16? It implies, okay, x over 3 equals 16 over x. X over 3 equals 16 over x. Of course, when you cross multiply, you get x squared equals 48, and you simplify that. Okay? Likewise, if we were to say, oh, well, what is the geometric mean between root 8 and root 2? Well, it would be x over root 8 equals, okay, root 2 over x. X over root 8 equals root 2 over x. When you cross multiply, you get x squared equals the square root of 16, okay, which implies that x is equal to 4. So the worksheet, okay, we're going to ask you to do is first off, look at defining what this geometric mean is, okay, and look at some examples with that, okay. And so going back to the book again, okay, the geometric mean between 4 and 18. 4 over x equals x over 18, okay. Cross multiply, solve for x. That's going to be a big idea. Actually, I'm going to terminate this video now, and then we'll talk about it as it applies to the geometry.